This is a demo of DataExpress Open Platform, or DXOP. We are looking at a high-level diagram of the hardware architecture for a typical DXOP environment. On the left side are the core and database servers that would reside on the internal network. Our secure gateway servers would reside in the DMZ, normally configured in pairs, and on the right side we see a router out to the internet. Before moving into the application demonstration, it is best to understand the DXOP application process and security models, making it easier to understand the flow of the objects within the application. From a process perspective, all the file transfers that are set up and configured are based on endpoint control, where an endpoint represents a server or the file transfer software that's running on that server. Endpoints may be external trading partners or internal servers that are either the source or destination of the data. To define a file transfer, we must first define an endpoint group, which will help us create a user or an operator's visibility into the system. What is important to understand at this point is that we must define an endpoint group that an endpoint will be associated with. Only when endpoints are created are we able to build our file transfer job templates. The job template is made up of individual job steps. Each job step represents a protocol which can either be a communication protocol or a work function. For each job template, we can schedule the execution of that job template and build any notifications required for that job template. Each job step will have a set of job step properties, which are the parameters that are fed into the job step. If it's an FTP client job step, then all the properties associated with that will be FTP client-related parameters. Once we have our job step template built with job steps, we are then able to execute the jobs and spawn unique executable jobs. Each of these represents a different job, sending or receiving a different file. Up at the top here with our endpoint groups, we see an operator or user defined. I will use the term user generally. The user is defined to DataExpress, and that user is associated with an endpoint group. When the user logs in, they have visibility to just those endpoints that are in the endpoint group they are associated with. Each user can be associated with one or more roles made up of privileges, which defines that user's permissions within DataExpress. Now let's look at DataExpress Open Platform through our browser-based interface, logging on with our demo user. This has brought me to the screen for the file systems that are associated with this DXOP application. One of the first things that needs to occur in a new installation of a DXOP system is to define where the application is going to store transmitted data files. To do this, we point to a named file system that we create by right-clicking and adding a file system. This field should contain the path on disk that the file system would be pointing to. It can be a physical drive on the server itself or network-attached storage, like the file system listed above here. Only when we have our file systems can we start building endpoints and jobs. On this endpoint screen, we see a couple of endpoints listed. To create a new endpoint or endpoint group, simply right-click and add a group in the pop-up. We are just going to put a number in there, and we can save it and close out of that window. With an endpoint group defined, on my endpoint panes, I can add an endpoint. I check which group I want to be in. I'm going to put it in my demo group so that we can see it. I'll give it a name and ID and relate it to the file system we intend using. So, let's go to my demo file system and make it active and save. Now we have a new endpoint. If required, we can add contacts for that endpoint. There are also properties that can be associated with the endpoint that can be inherited by each job template, basically the parameters for specific jobs. But you can define them here at the endpoint level, which allows them to be inherited by individual job and job step levels. Once we have our endpoints, we can start building our job templates. From the job templates screen, I'm going to scan down to find my Demo 1 jobs, which are job templates that I built already. Again, if you wanted to add a new one, right-click and your menu pops up with a new job. For now, we are just going to use this simple FTP client get and put. In this job, which has a name and ID, scrolling across will display the endpoint that it's associated with. Once we have that information, we need to add some job steps. In this particular case, I have two job steps. The first one is an FTP client GET, and the second job step is an FTP client PUT. In each job step, scrolling to the right, we define the protocol for that specific job step. You can see that this job step is going to use FTP client GET. But we could have selected any protocol we support for collecting files by pulling up the edit screen for this job step. We will stay with FTP client GET and close out of here. Within the FTP client GET step, notice the success and fail steps here. Within our job step structure, conditional branching allows us to tell the application within the job what it should do after either a job step is successful or if it fails. In this case, if my GET step is successful, I am telling it to move to the PUT step. We could add an additional job step in here, so if this job step fails, the file could be moved with a disk put to an archive location where it can be examined by an operator, for instance. That demonstrates what conditional branching can be used for. For the FTP client GET step, we have job step parameters listed to the right, and many of these are just typical FTP client parameters: IP address, user ID, password. Notice that the password is encrypted, which is also how it is stored in the database. Other parameters include a remote directory, remote port, and the ability to delete files, scrub remote files, true or false, active or passive mode, source file list, and we have a duplicate file check. If we set that to true for duplicate file check on all the collection steps, then we would keep a hash value of a cyclic redundancy check or CRC of the file. Then with each subsequent file that we get for this same job and job step, a comparison of the hash value would tell us if the file content was the same. If so, we would flag it as a duplicate in our console. The user would then intervene and decide either to stop the file from continuing to process or acknowledge and release it. For each job template, we can define schedules. In this case, I have a schedule named daily defined, although its frequency is weekly, but we have all different options for scheduling. Selecting a frequency of weekly shows specific days of the week, then we can select what days we want the transfer to occur. While this one has a specific time, you could have a list of different times. There are many options for daily, weekly, and monthly settings for our job schedule. On this screen, we also define notifications. We will add a new one for the FTP client PUT step. If it goes to success, then we choose one of these predefined templates, for example, customer files received, and we will send it to an email address and save that. When this job goes to success, a notification is sent out to the specified email address. I will execute a job now and schedule a job for later. Using the option to execute now, we see a message at the bottom that it executed successfully. This does not reflect the completion status. So, when we have a job that runs either manually, according to a schedule, or triggered by an external event such as an FTP client connecting into the FTP server, then we would see that here in the console. In our job console is the job I executed and the job status. You will see that both steps completed successfully and, in this case, the file went out of a secure gateway connected to the system rather than the core, so the job is set up to go out the secure gateway. On the console, we see all the messages from the execution. Both job steps show messages on the console itself. We see our notification archive that's different from the notification template that we saw on job templates. Here we have the notification archive showing the actual notification that was sent out, so the success here is true. Next, we list the job files, the files associated with this job that were sent out. I had to rename one of the job steps, so it renamed it from KB1 to this, 70_FCP_REN.bin. That was an example of setting up a simple job template, executing it, and looking at the results on the console. Another thing to look at under System Configuration is the gateway definition. On this system, we have the core server and only one secure gateway server. This is the screen where we would define any additional gateways. The system supports multiple holiday calendars down to the job level, and these identify when jobs are not to be triggered. Allowing different holidays for different endpoints facilitates endpoints or trading partners flexibility for adjusting their own days when file transfers shouldn't be scheduled. An example would be the differences between national and international holidays. Key management. DataExpress has functionality for managing PGP keys, SSH keys, and SSL certificates. Let's look at PGP keys first. We have both the public-private key pairs that can be added to the system, as well as any remote public keys that we would use for encrypting files to send out to a trading partner. For the local server keys, we can generate a new key pair if needed. We can also import and export key pairs, as well as delete as required. For the remote public keys, once we get a public key from a trading partner, we would then import that key into the DataExpress PGP key ring for use in a job or job step to encrypt data files to be sent to that specific trading partner. Looking now at SSH keys, there is a single key that's defined as the host key for the DXOP application. Additionally, there are local client SSH keys plus any remote server or client SSH keys defined. For the remote server, that's basically our host keys. The host keys of the remote servers that DataExpress would be connecting to are stored and displayed here. If a customer is connecting using key authentication, then we would have their key defined here. And if we are doing client authentication to the remote side, then we would have our keys stored here as well. Key management for SSL certificates. From this screen, we can generate an SSL key that can either be utilized or it could be sent off to a certificate authority with a certificate request. Once we receive the signed key back from a certificate authority, we import it here. Port definitions are very important. Within the application, we can define our communication ports. In this case, we have a handful of standard ports defined. Some are defined for the core server and others are for the gateway. If you notice, we have port 21, the same number, but one is defined for the core and the other is defined to be started as a listener on the secure gateway. For each port that we want to define, we must associate it with a port template. In this case, I have this FTP server port associated with this port template, and the port template shows what the port will look like. Here, we are binding to a specific IP address on that server, defining login and logout times, max times for idle login and port ranges, and an SSL certificate for that port. Once the port configuration is defined, when started, the port shows listening, and when it's not started, it shows stop. Roles and privileges. Roles are made up of a set of privileges, and naturally the administrator should have all privileges defined. However, something like DX Monitor is only going to have basic functionality like read-only, print, and query for many of the screens and many of the application's functions. To contrast that, something like FTP Standard only allows FTP communications. For your environment, you can either use the samples provided, or there are a combination of these privileges that can be selected. System preferences is a set of parameters allowing you to define specifics for your environment. While there are some tracing values used in troubleshooting that are helpful and may be needed periodically, most system preferences would be set once after installation and not modified thereafter. To demonstrate user properties, I'm going to pull up our FTP properties, which are global settings for our FTP user. Most of these are adjusted at the actual user level, but this screen is here for global defaults. The HTTP user properties define what the HTTP interface looks like. Most of these are not changed. There is a logo image file where we can change and adjust or customize the logo that will display on the HTTP pages, inserting your logo, for example. Another system configuration is the user setup for authentication in the application. Adding a new user is a right-click function. To add a new user, give it an ID, a name, and whether it has GUI access or not. Then we would enable the account and set a password, which is governed by different system preferences, specifying the number of characters, special character requirements, and any required capitalization. So, all of that is in system preferences, but the actual password gets defined here. Again, with a right-click, we can change a user password. On this screen, we associate the user to a role, and if there are any protocol properties specific to that user, we can define them down here at the bottom. If you recall, the user's visibility, discussed earlier, is configured here, where we define our endpoint groups for a particular user. Here, my demo user shows I have the 3 endpoint groups, including the one I added earlier. For our job configuration, there is one item here we didn't cover earlier for notification templates. When I added the notification to the job, I selected one of these notification templates. This is basically the skeleton of a message that would go out to the recipient if it's associated with a job or job step. You can see that we have these tags or symbolic values that can be inserted into any notification template, allowing you to create notifications that are meaningful to the message recipients. Looking at monitoring, we have seen the console. Let's look at executable jobs, jobs that have already been run or executed in the application. This screen is probably most useful on a failed job. You can come to this screen and change a value. If there was a failed job here, you could change the protocol parameter in the job step itself and then restart that job with that new parameter. This is useful if a password has changed on the remote side. Once you have the new password, you can insert that new password into the job step and its parameters and restart that job in order to get that file transmitted. Our file screen shows all the files and information about those files, what job step it came in on, where it's actually located in the file system path, and the folder it's held in within the DXOP file warehouse. So, all the information we need about the files themselves would be seen on this screen. The Gateway Monitor checks the secure gateway. If there happen to be any jobs currently running, we would see which jobs are executing across the gateway down in this lower section. Message Log shows us all the system messages and running job-related messages on a rolling basis. Our port monitor is the best place to see what ports are listening, and this is also where we would see transmitted files. Files that are being transmitted currently, instead of a listening port, we would see a transmitting port. If a user is connected but not actually transmitting at the time, we would see navigating. So this is where we can see if ports are actively transferring any files. The Schedule Monitor shows all the jobs scheduled for a particular period of time, so we have a view to what is scheduled for a future period of time. From a monitoring perspective, we also have reports that we can pull up. There are about 30 canned reports you can run, plus you can generate or add your own report. For our access log, for example, we can change this date here, save that, and then run the report. This access log report shows who logged into the application and when they were in the application, what they did, what IP address they logged in from, and whether the attempt of what they were doing was successful or not. That's just an example of the reports that can be run. Under Help, we have some system information. About gives us information about the server we are running on that can be used for support purposes, as well as documentation that can be pulled up on the DXOP wiki page. Finally, there is the Log Off option.